We have enough participants, so let start the discussion. Uh,
Why am I not able to hear?
Ma'am, are you here? Dr. Bidyut Kumar Patra is currently working as an associate professor in the Department of Computer Science and Engineering, Indian Institute of Technology, Varanasi, which is nothing but Benares Hindu University. He earned his PhD degree in Computer Science and Engineering from Indian Institute of Technology, Guwahati, under the supervision of Professor Sukumar Nandi. He is the recipient of ERCIM Fellowship from European Research Consortium of Informatics and Mathematics, France, for doing his postdoctoral research at VIT Technical Research Center of Finland. His research interests include data mining, machine learning, anomaly detection, recommender system, and education technology. Dr. Patra is the recipient of Best Teacher Award 2021 by National Institute of Technology, Rourkela. Now, I would like to invite Dr. Patra to take the baton. Dr. Patra, the stage is all yours. Thank you.
Yeah, thank you very much for nice introduction. And then it is really my privilege to be associated with SOA 6 and Anusandhan University. Especially thanks goes to my friend Pratik Datta, and I have other students there also. So I know the 6 and Anusandhan from the quite some time. So I was also associated with IIT Rourkela. So let me start my talk. Let me share the content. Yeah, since I was already. Now I cannot see the screen. Actually, the desired screen is not showing it. So,
Yes, sir.
actually, the content which I wish to share is not showing. So I see sometimes we can see not skip the time. So, yeah, now it's fine. Yeah, I think you can see the screen. Everyone can see the screen right now, right?
Yes. Yeah.
Yeah. Hope that everything will go smoothly. Actually, because of today is Saturday, we do not have power backup. So if power goes, then I need some time to set up again. Okay. So really, as I said earlier, I am really thankful to SOA. So topic is introduction to recommender system. So, and then as I was told, there will be students along with other faculty member. So I will take your questions from both sides, but I will give more importance to the students. So therefore, I will go slow in some point, in some slide. Maybe I will be repeating. Okay. So today I will be talking about introduction to recommender system, and then some recent topic that I will just tell, and then what I'll be talking about some recent work, that is streaming recommender system. It is very easy, but easy work, but published in a reputed conference. And then, if time permits, I'll be talking about what I was doing at United Rourkela. So as we can see, this first slide, we have many pictures of headphone. And then let's say the scenario that I wish to purchase one set of headphone. In this scenario, what we see, we have the huge information, but I am a bit perplexed to choose the right decision. This is the typical scenario for the information overload. This is something called information overload. We have huge information, but we are unable to take the right decision to choose which, to take a right decision on a particular product that which one I should purchase. So, in this scenario, actually, recommender system is here to help the customer or consumer in different domains. So, recommender system help people cope with information about the problem in this digital era. There are many applications of recommender system. We can see in the OTT platform, even e-learning course, that is Coursera also have. Coursera also introduced the recommender system in their platform. Similarly, we can see in the Netflix, Amazon, YouTube, and Flipkart, and so on. So it has a huge application of recommender system. So these are the all story I said. Where is the applications domain, and then introduction, and then I go to the more detail in technical part in the next slide. So this slide is something like that. We will be talking about more in the technical part. So first recommender system was introduced in 90s in the last century, and after that there are many recommender systems have been evolved over the time. So last 30 years, and these recommender system could be divided into three major categories, or this algorithm could be divided into three major categories based on the basis that what type of information these algorithms they process. So as we can see, there are three types of recommender system. One is content based, another is collaborative filtering, and then mixture of these two is the hybrid. So in case of the content based, basically it needs the information of the consumer or users, and as well as the information of the item. But information in form of very specifically one needs to tell that what for users, what should be the age, what should be the demographic information, what should be the occupation, and so on. On the other hand, item also needs to be described very nicely, like what should be the color, what is the category, and what is the price, and so on. Then in case of the content-based recommender system, basically it matches the user profile with the content. See, sometimes if I mention is the maybe like this here, say I like the red color. So then it may match the color of any T-shirt of red with my profile, and then it can recommend. So, but as you see, is people are being reluctant, and people don't have time to describe this, or people more reluctant to express or to disclose their occupation and age and so other information. So therefore, content-based recommender system is not useful for many other scenarios. Like, see, example in the item-based profile. Let's say I watch a short movie in YouTube. I like that movie. Okay, let's say not movie, even say let's say very short video, 2 to 3 minutes video. I like that somehow, but it is very described. It is very difficult for me see for which features I like it. Okay, maybe some expert they can argue that okay, I can clearly tell for which reason I like, but for a novice and other guys, it is very difficult to describe why do I like that movie. My point here is that in some what is called product or some item, it is really described. It is very difficult to describe in terms of the characterizing the item. So therefore, content based is not used for many applications. On the other hand, there is something called collaborative filtering. I like the movie, so I can tell I like the movie in terms of the scale 4 out of say in the scale of range from 1 to 5. I like the other movie in the scale of 5. So therefore, I can able to distinguish. So ideally, in this case, or in case of the collaborative filtering, it does not need any content information. And as I said, this why do I share my occupations, or so let's say some other sensitive information to with the, say, let's say, with Amazon and so on. Instead of, I can say, okay, I like this movie, so I'm giving the ratings 5 and 4, and that we are habituated in the scenario, like after purchasing product from Amazon, Amazon asks that what rating you can give and so on. So collaborative filtering basically it process the rating data set. What is there in the rating data set? Each user will have preferences over the items. Okay. And nowadays, people also write the reviews, so it can be converted, corresponding review can be converted into the corresponding rating, and that could be used by the collaborative filtering. And then hybrid approach is like, in some scenario that I will be talking later, the collaborative filtering does not work very well. In that scenario, that we need to take the help of the content based. So this is a mixture of everything, is called the hybrid approach. For all these collaborative, all these approaches, among these all approaches, actually collaborative filtering is very popular in academic scenario, as well as also in industry they use mixture of everything. Okay. So ideally, what happened after that, for all recommender system, it predicts some rating about the items, and then if the rating is above some threshold value, then it recommend, and it cannot recommend, say, let's say 100 products. So therefore, we should ideally they should recommend only, say, limited number of products. So let's say that is something called the top end. Okay. So now what I do it, we'll focus more on collaborative filtering. In summary, in case of the collaborative filtering, we need only the rating data set. We don't need the all other information. Okay. So in collaborative filtering also is divided into two major categories. One is called the user-based, one is called the neighborhood-based approach, and another is called the model-based approach. That I will be talking in the next few slides. So here is, as I said, the neighborhood-based approach, again divided into user-based and item-based. So here is the typical scenario for the user-based. So we have set of users and we have set of items, and the dark line indicates that this user, this woman has consumed the item grapes, and then strawberry, and then this watermelon and orange. Okay. And the dotted line indicates whether that would be recommended to the guys or not. Okay, so this is the explanation of the figure. Now let's say my task is that whether we'll check whether these grapes could be recommended to this guy or not. So how user-based collaborative filtering works? It will look to the other users which are similar to the concerned users. In other way around, so my preferences mostly depends, my recommendation will be based on my closeness with the other users. Okay. So therefore, what it is done, it will be finding the this method, like user based, will compute the distance from this concerned guy with the all other users who have consumed these item grapes. So here what we can see, this lady, she has consumed the item grapes, and then we compute the similarity. Similarly, if there may be some other users also will compute the similarity, and based on their taste, we can tell whether these grapes could be recommended or not. So I'll be explaining more detail in the next slide. So here my point is, when we talk about the user based, we will find the user to user similarity. Now when we talk about the item based collaborative filtering, what we will do it? So my task remains same, whether the grapes could be recommended to this user or not. What we will do it? We will compute the similarity between the concerned item with the item consumed by this man. Okay, this man has consumed because this is a dark line, so we will compute the similarity. Okay, and if we find that similarity is quite good, that means this item is same as this one, so this could be recommended. Okay, So next slide, it will be much more clear with one simple example. Here we go. So as I said that we'll have a user item rating matrix. Each user has rated the item with some value in the scale from, let's say, 1 to 5, and then we have 5 users. Now let's say we have to tell whether I4, that item I4 could be recommended to user U4 or not. So what is the first step? First, we have to identify the users who have rated the item I4. So find the similar user of the active user. So in technical term, for the user for whom we are trying to find the recommendation is called the active users. Okay, so here U4 is the active user. And for the item which we are planning whether we recommend or not, that item is called the target item. Okay. So first, what we will find? So we find whether the target item, who are the users consume this target item. So the user U1, U2, U3, and then U5. So U1, U2, U3, and U5. Now what we will do it? We will find the similarity between U4 with U1. We find the similarity between U4 with U2, U4 with U3, and U4 with U5. Okay. So we'll get a kind of similarity value. So and then that similarity value will be used for what rating he could have given. So if he purchased it. Okay. So this is the scenario here. Once we find the similar users, and now we will check what is the rating of the similar users. Let's say here rating is 3, 1, 4, 4, 8, 8, 5, 13. So 13 divided by 4. So that is the simple. What we do it, we can take the rating average of the users who have rated the target item. Okay, this is the easiest way, and then we can say this will be 3 point something. So other way around, what can be done is let's say user U3 is very close to U4, which compared to U2 and U1. What we do it when we take a kind of decision, we ask our close friend whether my decision is correct or not. And then I have some other friends along with the closest friend. So I ask also them. But while giving importance, we give more importance to the friend who is close to me. Similarly, what can be done is the users which are very close to user U4 that rating will get more important than the other rating. So therefore, what is done is that similarity value is multiplied with the rating of the other user. So and then it is normalized. So that way the rating is predicted, and if we see the items rating, predicted rating is above some threshold, then we will recommend the item I4. Okay, this is something we talk about the user-based collaborative filtering. Okay, so yeah. So other is item-based collaborative filtering. So it is a kind of opposite to the user-based collaborative filtering. Here we go for item-based collaborative filtering. Task remains same whether item I4 could be recommended to U4 or not. Okay, so this is the task. What we do in earlier case, what we found the similarity between U4 with U3, the items which are consumed, and then U4 with U2 and U4 with U1 and so on. But in case of the item-based collaborative filtering, which is more what is called is popular than user-based. In case of the item-based collaborative filtering, my target item is U4. What I do it, and then active user is U4, target item is I4. What you do, I compute the similarity between target item with the item consumed by user U4. So in this example I3, I will compute the similarity between I4 with I3. I will compute the similarity between I4 with I2 because I2 is also consumed by U4, and similarly I4 with I1. But I will not compute the similarity value between I4 with I5 because I5 is not consumed. Now we computed the similarity value. So one easiest way, as I said earlier, so how do you aggregate it? You take the average of this. Okay. So it will come something 4 point something. So earlier it was coming 3 point something, so it is coming 4 point something. Okay. Now, similarly, this item could be very close to I4 with respect to I2. So therefore, this rating will get more importance than the other rating. So therefore, this similarity value between item to item is multiplied with the rating here. Now it is not only the rating, is there is something called, what is called is, there is a deviation. So from the average. Why it is so? Because see, let's say what you see in academic scenarios, some teachers are very strict and some teachers are very lenient to giving marks. Okay, but how do you identify that who is very lenient and who is very strict? So you take the average of the marks obtained by the students. Okay, so if the average is quite high, so then that teacher is quite lenient, and then otherwise it is very strict. But to match, okay, so to match, what you do it to to capture this essence, whether it is strict user or lenient user, what you do it? So whatever the score is given, we subtract from the mean. So that is the scenario that we can see in earlier slide. Also, we did the same thing. Okay. So we talk about two major approach. That is the two major approaches. That is the item-based collaborative tutoring and user-based collaborative. So these two categories basically comes under neighborhood-based approach. Okay. Next, I talk about similarity value. Right. So there are many similarity values, but mostly here, instead of telling about similarity value generally confined between, it is a value above 0. Okay. So, but here, what we do it here, we found, instead of similarity value, we found a kind of correlation. Like here, some correlation we compute user to user. That is, I was talking about the similarity value. So here it can be positive and negative. Obviously, similar means it should be above 0. And there is another famous similarity value. So that is only positive here. That is Jaccard similarity. So it is also quite old, say 1890 or something, 1890 was introduced. Okay. And then recently introduced 2005 or 2002. That is something called adjusted cosine. So it is used to compute the similarity between item to item, and then Pearson is used for user to user. I am not explaining in details. That you can go through once you have the interest in this area. Okay. So now I will be talking about one model-based approach. Okay. So model-based approach is like if you heard about the classification technique in machine learning, and I very clearly I explain something called decision tree. So there are other model-based approach apart from the k-nearest neighbor in classification. So model-based approach, what happened actually, once the model is built, there is no need of tracing the what is called is the original training data set for providing the prediction about the class level. Okay. So that is, the model is built and then model will give you the output. So this happens for the support vector machines and all other classifier apart from the k-nearest neighbor. So here also, given the training example, here in this example rating data set, a model is built, and then once model is built, no need for looking into the original rating data set. So one simplest model-based approach was proposed in 2005. And it is so easy, and it was published in a very highly reputed conference in Siam Data Mining Conference. What is the idea? Idea is that there are two users. User A has rated, and there are two items, let's say, for simplicity. So user A has rated 1, and another he has rated 1.5. User B also has rated the item I with 2, but we don't know the rating, and that is the task we should tell what rating he could have given. Okay. So idea says that, so you take the differences. So here difference is 0.5 and then you add the differences with here. So that is you add 2 which the difference is and whatever this value, so that should be the rating. Okay, so that is the idea. Its idea is so simple. Now as you understand, there will be many users, not only a pair of users, there will be similarly many items, not only a pair of items. So here idea is that you compute the differences across the all user between a pair of items. So I repeat it. Okay. So let's say I have a pair of items here. I need to compute the deviation between this pair of items. What I do it, I will compute the differences here. I will compute the differences here if there is rating and so on, and then I will take the average. So that is something called deviation of item I and j. So this is plain the difference. It could be positive, it could be negative also. Okay, and the number of user is divided. So once you get the deviation, now what you have to do it, you have to tell the rating here. So user B not only rated the item I, he must have rated the all other items. Let's say item K, item J, and so on. What is that? It is not only compute the deviation between a pair of items, you compute the deviation between multiple pair of items. The other item, one is target item, another is the item already consumed by the user B, because we have to tell the prediction for the user B only. So now what you do it, you take what is the average, because average plays is very big role, because if I am very strict user, so my average will be, so let's say 1 to 5 scale, it will be say close to 3.5 or 4. But the users who are always happy to give the rating for any product, so his average will be above 4. So therefore, what is done is, it's not only the deviation, so along with the average of the users is also taken care here. So average of the user plus, so what is the deviation for all other cases? Deviation between item J with item I, deviation between item J with other items, deviation between item J with other items, and so on. So this is so simple, that was long back in 2005. So I think you must have understood. So let's say what is the task? Task remains same. I have to tell what rating could be given by the user U4 over the item I4. Okay. So what I have to do it? There are consumed item is I4, I2, I3. I will compute the deviation between I4 with I3. That is 4 minus 3, 4 minus 4 divided by 2. For I4 with I3, what I do it? So, and then you have to see one thing, that items, pair of items should be rated by the same user. In a sense, this I cannot take, because we don't know when we compute the division between I4 and I3, I only take the ratings coming from the user U1, user U3. No, I cannot take, because we don't know the rating, what is the rating here. So therefore, you have to see the users who rated both the items, then only we consider those rating into the deviation. As I said here, we should compute I4 with I3, I compute with I4 with I2, and I4 with I1, and then we got the 3 deviation. We take the average, and then deviations average, and then what we do is the rating average of the user. Okay, so that is so simple for the model-based approach. So there are other complex things, but that is something called metric factorization. But it is not today's. I plan not to talk about. So, but just you can, if someone is very interested, one can note down that there is something called metric factorization in recommendation, okay, or recommender system. So now there are few interesting challenges in recommender system. One is called the long tail item recommendation. So what happened actually, there is something called 80%, 20% rule. So please note it very carefully. 80%, 20% rule is something like that. So let's say we have 100 items. Okay. So there is a scenario like 80% of the total items, that means 80 items, will receive 20% of the total ratings. and 20% of the total item receive 80% of the total rating. Total rating means, so sorry, if I move back here, ratings means total number of ratings. So here 1 to 3 to 5 and then 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So here in this example we have total 16 rating. 16. Now total number of rating is 16. That is I am saying. So now I repeat it. So 80% of the total item receive only 20% of the rating, and 20% of the total item receive 80% of the rating. Okay. So therefore, what we conclude that most of the items receive very less number of rating. Only there are few items which receive many number of rating. That means the item which receive rating means those items are getting purchased repeatedly. On the other hand, the items which basically receive very less number of ratings, they are not getting purchased by the customer. So those items are called the long tail item. So items which receive very few ratings are called the long tail item. And what happened, whatever the algorithm is, so much development we made or the scientists made, is like most of the algorithm focus on only on recommending the popular item or those 20% item. There are very few algorithms which basically focusing for providing recommendation for long tail item or 80% of the total items. Okay. So this scenario is called the long tail item recommendation. So of late there we can see some work on providing recommendation from long tail items. Okay. So yeah, if you have any question, I think we can take the question later. So now in a scenario that is cold start user, let's say I am new to the system. Means system does not have any history about myself. In a sense, I did not purchase anything, but I used to purchase through Amazon. So in that sense, what happened? Amazon should not recommend me. So that is the scenario is something called cold start scenario. So it could be from the user perspective. User is new into the system. So that is something called the cold start user. And there may be the new product is getting added, but user is not aware, system is not aware. So because there is very less number of rating or no rating, as I said, the present recommender system basically it recommends those items which receive many ratings. But let's say what is called the 0 day launch. So first day product. So there is no history. There is no one purchased as item. So therefore, how that should come into the recommended basket of the users. That recommender system should look into. So that is another research area what people can look into. Here actually content information play a vital role. As I said, the content-based recommender system also used in some scenarios. Then this is another very interesting research topic in recommendation is called the diversity. Diversity is like say I purchased today one tab from the Amazon, and if the next day also the Amazon recommender system again they recommend the tab from the other company, it's not very justifiable thing. Because I have already spent money and then laptop tab is something like that, I cannot purchase every day. Okay? Or even I cannot afford purchasing every 6 months and so on. So therefore, recommender system should recommend the item which are diversified item, which are diverse in nature. Let's say somehow recommender system should understand me, and if it's recommend something, say novel written by Taylor, then I'll be very happy to see, okay, yeah, recommender system knows somehow me, and it knows somehow, it knows my characteristics or preferences and recommending a really beautiful item which really I wish to purchase. Okay, so that is there should be a diversity among the recommended item. So that is something called putting the diversity into the recommendation. That area is also very new. I think first notable paper was published in 2012 only. And then is another beautiful area is something called group recommendation. So a group of friends decided to move to a theater, but problem is which movie they will watch. Okay, or they decided to go for tour, so they should decide actually how to start and for where they should go. So that means recommender system is not the individual; it should recommend a group of people. So that is really challenging as you understand. When you have a group, you will have a diverse opinion, but still you have to progress together. So that is something called group recommendation. And then recommendation in social media, Facebook asks for Facebook also provide the friends recommendations. Not only that, so you are you work you attach with some social media, but you when you landed in London, you wish to go in some restaurant. So recommender system may provide some kind of which restaurant you should go, because there actually you are new, there is no information, but you already some information is there in the system. So based on that, recommender system should provide some information or some recommendation. And then is something called session-based recommender system. Session-based recommender system is like, so I am new to the system, so I don't want to log in to the Amazon or Flipkart. So I want to see what are the products available. That is we do, and then when we go for purchasing, then only we give the credits. Yeah. But
message PNB credited
I think there is something cross.
No, that was fast. Second level one other.
Division sir, look into this matter, please.
Is there any issue or someone is asking?
No, sir. Actually, someone by default has, I think, turned on the microphone. That is why we are just looking into it. Okay. Please,
yeah.
please
Okay.
carry on.
So another scenario is something called streaming recommender system. Streaming recommender system. What happened? Whatever the recommender system I talked today, like user-based, item-based, and then another is like and then multi-factorization. What happened actually? Many things are pre-computed. Let's say similarity. So similarities are computed, let's say 1 to 3 days before, and based on that, recommendations are given to users or consumers. But here is like within 2-3 days, there may be huge change in the rating pattern in the database, and as you imagine for a Amazon platform, so there may be, let's say, if it is not million, at least few thousand of users purchasing the item at the same time, and they are giving the responses or ratings. So therefore, there will be huge change in the database in terms of whatever we computed 2-3 days back. Okay. So now here proposal here is like we should compute the whatever we need to compute, like similarity values and other preferences. So whenever there is any change in the rating information, so that is something called streaming recommender system. Okay. So I will show you one example in case of the streaming recommender system. We did a small work but published in a good conference that I will show you. So these are the stories. Why do you need for the streaming recommender system? I already told. So let's say if it is not 2-3 days, let's say in some system they compute similarities, let's say 1 month before. So within a month, I must have what is called is like I must have changed my preferences within a month. So therefore, whatever the system recommend based on my 1 month's preferences, now I no longer I need those things. Okay, so these are the scenario to need to be basically streaming recommender system address. Okay, so what I do it, I go through one that is very easy, and why I wish to discuss it. It is so easy that anyone can can understand and come up with a solution, because this area is very new. I do not see much work in the streaming recommender system, whereas we see the many work on the what is called this earlier topic is like session-based recommender system. Okay, so same thing that rating database we have, just we present it in different way. Here we have the user ID, item ID, rating, and then user, and then what we can do from this database, we can compute the user mean. So for this user U1 has mean 4.5, so this is also user U1, so obviously it should be 4.5. And item mean, item 1, I1 item mean is 4, I2 mean is 4.5, so I1 is 4. So in that data set we can compute the user mean and then item mean. Okay. So now this work was published in ACMDOA, is a reputed journal, and in 2011 this work is also very easy. Okay. So how do you do it? We already computed the user mean and item mean. We further compute another two parameters. One is called the user tendency and another is called the item tendency. So what is user tendency? Is like what is my tendency of giving rating on an item over the other user who have already given the rating on the same item. So in simplicity, let's say I need to compute the user use corresponding user tendency. What I will do it, I will check out the what are the item I rated. So I rated the item, let's say 6 item I have rated, and then whether my rating is above the item's average rating. Let's say the item is, let's say Titanic is a movie. So Titanic movie, everyone give 5 ratings. Okay, so average, let's say 4, 5 or something like that, 4 and 5. So average will be, let's say 4.8. So this is the average. Okay. Now I give rating essentially. So that means my preferences on the item is negative, because from the population they gave the rating on the movie that is Titanic. So that is something my tendency. And there is some movie, let's say very not very high star movie, where the rating is like 2. Okay, average rating of the all other users they have given on the same movie, and myself I gave the rating 5. So that means actually whatever my tendency for that item is positive, and some other cases it is negative. So this is something called user tendency. If the user tendency and then user has rated not only one item, so multiple items, so I will compute the for all items rated by myself. So that is something called user tendency. Similarly, in case of the item tendency, whether the item, whatever the rating it received, whether it is above the user's average or not. So this is here the item received rating, and then whether that rating is above the user's average or not. That means this user has given the rating, let's say 4. However, the user's average rating is 3. That means he is really liking that item. So from there we compute the item tendency. Now we computed the user tendency, item tendency from this database. And now how do you do it? So once we compute the user's mean, item means, and then user tendency and item tendency, then we can predict. If both are positive, that means item tendency is positive and user tendency is both are positive. That means he is always giving rating above the user, above the item's average, and I can also receive the rating above the user's average. So then we say is the maximum of these two values, and similarly there will be other 4 different combinations, and then these are the work, not our work, so they will do it. My point is here, so this work cannot be used in a streaming scenario. What we made it, we change it, and then we modify it so that it should work in a streaming scenario. So what is the task we did it, now I'll show in the next. Yeah. So item tendency, this is the formula, but problem is with item tendency is remain. So here argument is that item tendency remain unchecked across the users. What is mean is like item tendency may be positive for me, may not be positive for others. But whatever how they treated, we argue that item tendency should be associated with the users. It should not be the same for the across the users, and then we address it. So this is the title of the paper published in ECIR. So that is European Conference in Information Retrieval. So this is what is called Core A conference. Okay. So I will take another, let's say, 5 minutes to complete this part. So this is very easy, as I said. So here, that is user tendency. How whenever new ratings come, how user tendency should be changed, must be changed if we claim that this algorithm is workable in streaming scenario. So now here, this is the formula earlier we wrote it here earlier. So what we do, we refresh it. This is very easy, as we can see. This is nothing but the summation over the user giving the rating. So let's say if one user give the rating 4, 5, 6, 7, so we add it. So that is something called RU, summation over RU. Now, what is this one? This is items average. Okay. So to compute the user tendency, we need to compute two things. One is users total rating, and then items average, and then we need to sum up. So therefore, AU minus BU by C. The point is that now scenario number 1, that user newly rate the item X. So because there is any change in the streaming scenario, so whatever the item he had rated earlier, so now he rates new item. So that item is X. Now how do I change the user tendency here? So therefore, this is the what AU is total number of rated, total number of rating. So new rate, I should add it AU plus whatever the rating given. So this will be changed. It is not only that, this will also be changed because this is the items average. New item is coming into the system, means in the summation. So that also will change. How we change it here? So new rating, that is AU, will change with RUX. RUX is denoting the new rating by user U on the item X. So this is changed. This should be changed. It should not be AU. Instead of it should be AU prime. Now we need to change BU. How do you change it? BU, within BU, that new item is not there because this item is the new one. It was not earlier. So, but we keep track of the items average. So item average we know for the new item X. So we multiply it with how many users rated the item, and then new rating is added, and we take the average. That's all. So therefore, whatever we got in value, that should be added with BU. So therefore, what is the new tendency? New tendency will be AU dash and then BU dash. Okay, and then obviously this is also changed. IU will change with IU plus 1. So that is we change. So this is the only scenario 1. Now another scenario is here. What is that? So this is different formula here, AU minus BU. So here scenario is that user V newly rate item X. Okay. So how it will change? Which was provided, which was previously rated by user U. What does it mean actually? So in earlier case, what we see in this way, that here we have seen that AU will be added. Now here is actually because new user rated trace item, and then how it will affect the other users. So other user is B in this example. So I need to change what will be the tendency for the other user. So other user did not rate the new item, so this will be fixed. Only thing will change is this one, because within this one, old item was there, which was there earlier. That average will change now. Okay. So here, So what was the earlier average of the item, say Rx? So this was the average here, and new item is coming RPX. So this will be the new average. Now within this one also the old average was there. So what we have to do? We have to subtract the old average here, and we will add the new average. That's all. So it is so easy. So then we will change only this one, and we will not change any other thing. Okay, because these user did not rate the item. It is the all other users rated the item. So that is we gave the name. Okay. So this way we change here. And next, what we do it? We said we talk about the what is called is the we talk about the similarity measures, Jacob similarity measure. Yes, Jacob similarity measure. So it is a kind of variant of Jacob similarity measures. So if we need to find the similarity between a pair of users. So if the new ratings come in, it is a like one. So simply we'll add it here and then we'll add it here. So that is we did it here. So that's all, and then ultimately we compute the personalized item tendency. So and so on. So that is the I think you can go. But only I wanted to show here that how so simple thing will change the address. Will address the problem of the streaming scenario. Obviously, this is not a so sophisticated algorithm, but obviously it is at part of the say all other say user based and item based one. Okay. So I will stop with another 2-3 minutes, and then I will be expecting something more questions, and then I will address. So as I said, the session based recommender system, that is long term user model, are often not available for a large fraction of the users. So user won't be the first time on the platform. So then I will see only the new session, and within the session, system should so that what are the items is available to the to you. It will show the what are the item available in the store, and based on that I will purchase. Okay. So here is the why do you need the session based? Some statistics we need to show you here that for common e-commerce company, more than half of all sessions are non-log. That means people are reluctant to use credential for window shopping kind of thing, even in the final shopping also. So no past interaction of the users are known. So then how do you use the user based, item based? You cannot use, right? How do you compute the similarity? Because no rating informations are there. Most sessions are window shopping one, where users are only looking for the product availability, price and the information. But if they like, they may also purchase it. So therefore, only 2.53% of the all sessions convert to the transaction. That means they are not happy. We may conclude that they are not happy with the recommendation, and that is why after spending some time within a session, let's say 10-20 minutes after watching a different product, and then they are not liking and they are leaving, they are not purchasing the product. Okay. So therefore, what we have to do it. This is the more formal way. It's like task of session-based recommenders is to predict what a user would like to click next when her current session is given. Let's say, given X, what is X? Means user has already watched item X1, item X2, item Xn, item Xn. Okay, n-1 and Xn. Now, recommender system should produce a right item which he or she may like. So this is the task of the recommendation. Given this set of item, let's say item 1, item 2, item 25, item 35, item 48, and so on. So system has to provide an item. So let's say item say 100 item, and that should be liked by the users. So therefore, we have to build a model. So and then it will produce a set of items, not one item, and then which one that user may like. So that is the problem, and this is the solution. Okay. So I'm not going any details about the any methods, but this is very current topic. So topic started people started talking much more after introduction of the deep learning technique. So in 2016, it was first paper in session-based recommender system where the deep learning technique was used. Okay. So that's all I think, and these are the things when I was in Raurkela, my students used to do work in different area. I can tell within a minutes here. We work in a project, like recommender system we were talking about. So can you build a what is called is cognitive recommender system where we work on extracting the EEG signal of the brain of the students who are watching some educational video, and then we analyze it. Okay, so these are the scenario, and then we work on development of city traffic dashboard based on the social media, Twitter information, and then GPS information from a particular place. We choose Bangalore for that. Okay. So I am thankful to my PhD students who are there in now who already completed for helping me prepare this these slides. So now I am okay for taking the questions.
Students, any question? Is there any question? Okay, so I have two questions. So whatever we have listened today, I think these are belong to collaborative recommendation system, isn't it, sir?
Yes, yes.
Okay, so can you please explain what is the difference between collaborative and content-based? Because recent topic is also based on the content-based recommender system. So I would like to give the I would like to basically hear the answer from you.
In content-based recommender system, basically in collaborative filtering, basically it works on only the rating information. So it does not need any kind of other information. Other information is like in content-based, what happened if we have some information like the users is from which demographic area. So let's say this guy is from, say, let's say in Kolkata. Okay. So
Okay.
obviously, I will system will give some recommendation which actually available or maybe people like in that particular region. So obviously, I will not our system should not provide a kind of recommendation which very rarely used by the some guy in Kolkata. Okay, this is all kind of comparison I tell you. In summary, actually, in content-based recommender system, algorithm use content information about the user's profile and then items description. Whereas in case of the collaborative filtering, it does not need any kind of information, only it needs the rating information, that is user has given what rating for particular product.
Okay. Okay.
Even the items information is whether this item color is red, whether item is electronics device, whether item is a food item is not. That information also not required in case of the collaborative. So
Okay,
everything just based on the metrics.
So in this regard, can we say content-based recommendation system is also item-based recommendation are the same?
No. Item-based recommender system is part of collaborative filter. So
Okay.
it is not the same.
Okay, sir. So anyone else? Okay, so Madhuri ma'am, Dibashandar sir, anything?
Sir, it was such a nice session I was listening to. Sir, thank you so much, sir, for your time. Our MTech and PhD scholars may need to get in touch with you. They may ask us for the video, sir, and for the PPT. So, can we get in touch with you, sir? Bidyut, sir? If
Yeah, I mean
a
they can
student
ask
has
question today also. No issue. Even if it is also they feel is very silly questions or they can ask me actually. Thing I
sir,
to ask, and then they can also later
few of the
contact
students
me.
are working in this area. recommender systems. A few students are working in this area, but I think they generally tend
But
to get
students are
back
there.
like,
Students in today is they are also working in recommender system.
so. So we
Okay.
would definitely like to get in touch with you for any possible collaboration and any guidance if our students need.
Sure, sure.
Thank you so much, sir.
Okay.
Thank you so much for your time, sir.
Okay, that's all. I think I can leave now.
Yeah, Pratik, sir, I think
Yeah.
on the behalf
Uh,
of the CSE department, let us give the vote of thanks, sir.
yes.
Okay. Thank you. Thank you. Is there any question or I can leave?
I think, sir, we are done. So,
Okay. Okay.
yeah.
Thank you. Thank you, Pratik. Yeah.
Thank you, sir.
Thank you, madam and HOD.